All right, so this example asks us to use dot plot to organize the data from the first example about the cell users. And then we're asked to conclude something about this graph. So again, just like a stem and leaf plot, you just label an axis with the numbers. And then above each number, you put a dot. So we have one for 78, we have one for 105, we have one for, say, or two for 132, and so on. One advantage of this is that it's really quick to do because you can just put little dots. One drawback is you lose the data isn't included inside of this data set, such as it is in a stem and leaf plot. So the conclusion we can make is that most values seem to cluster a little bit. So they cluster around 105 and 148. Right, there's a cluster between 105 and 148. And on top of that, we can see from here that there's a lot more dots on 125 than on any other number. So this occurs most at 126. Neat. So that's just a couple different ways aside from a frequency histogram on how to display numerical data or quantitative. Let's talk about displaying qualitative data. There's going to be a bunch. You've probably seen some before, maybe even used some in different classes. First and foremost is what is called a pie chart. And it's going to be a circle that is divided into sectors that represent categories. So the number of each earned degrees conferred in thousands in 2007 are shown in this table. We want to use a pie chart to organize the data, and then we're asked to conclude something. So to figure out the slice of the pie, we need to figure out the angle that creates. So we need to figure out the total frequency. Right, you're going to add these all up to get a number. Let's call that sigma f. Then we need to find the relative frequency of each one of these. So for instance, this one is going to be 728 divided by sigma f, and that gives us 0.24 to get our relative frequency. Then to figure out the angle, we need to do 0.24 of, well, a circle has a total of 360 degrees. So if you do this calculation, that's going to give you 86 degrees as the angle needed for the category of associates degrees. So when you're making this pie chart, you start by taking one radii, finding a central angle of 24 degrees, and then creating that sector. Then you do that for each and every one. So a bachelor's degree had 1525. You take 1525 divided by the total number of data points that you're looking at to give you the relative frequency of 0.51. You would take 0.51 times 360 degrees, and that's going to give you 184 degrees. And so in this pie chart, the category of bachelor's degrees is going to take up 184 degrees of this circle. And so things that we can conclude is that almost or more than half conferred are bachelor's degrees. So another way we can graph qualitative data is to use what is called Pareto graph or Pareto chart. And it's a vertical bar graph, in which the heights represent frequency or relative frequency, and the bars are positioned in order of decreasing height, with the tallest one positioned to the left. Right? Because we're dealing with qualitative data, we can't order it naturally. So what we're going to do is we're going to take the largest bar, put it to the left, and then the next largest bar, and so on, so that it kind of slants down like that. And here's an example of what a Pareto chart looks like. Notice that there is gaps between each one, just to really emphasize the fact that you're looking at not a histogram. Let's say that we have some sort of data set that has two parameters, like maybe time versus concentration of a substance, or time versus how much is left of a radioactive substance, something along those lines. And what we can do is we can also visualize these. So when entries in one data set correspond to one entry in a second data set, the sets are going to be called paired data sets. And so one way to graph paired data sets is to use what is called a scatter plot, where ordered pairs are graphed as points in the coordinate plane. So just like you did in algebra in high school, since you have two numbers, they're going to create an ordered pair, and then you just plot it in the coordinate plane. So this is useful to show any relationships between quantitative variables. And we'll return to scatter plots later this semester and do some analysis on figuring out how two different data sets are related and if there's any sort of relationship between them. But here's an example of what a scatter plot looks like. So each one of these dots in this plane corresponds to some number, which looks to be a petal length and a petal width. And you can kind of make an inference that it's fairly linear, right? You could probably get a line drawn in here that is close enough to each one of the points. And so what that would mean is that the longer the petal length, the wider it is. And so that's how you can kind of interpret what is happening with that scatter plot.